Hi everybody, this is Will. We're going to take a look at my house here in Hampden, Maine as an example of life cycle costing. I'm doing a deep energy retrofit, so we're going to go through a few items on that. Keep in mind that life cycle costing can be used on buildings of all sizes. All right, let's go check this out. First, we're going to walk through my outdoor office here. Everybody could use a little extra space, So, what I've done is added 4 inches of XPS foam insulation on top of the foundation and the walls and all the way around. You can't see the edge of the foam there, but I got 4 inches of foam that goes up on the outside of the wall here. And in this part of the building, I used zip sheathing and taped it up to seal it up. But the foam underneath is actually taped as well. So what we're looking at here is the original red cedar shake siding. I actually took this off the building, and you can see a pile over there on the other side of the driveway, but because I haven't done it all yet. So this is the system I'm using if I'm putting the cedar shakes back on. I've got 4 inches of foam, a layer of cedar breather, which allows water to drain down behind it, and then re-nailing those back on the side. Now I knew I wasn't going to have enough to cover the whole building, so I got some Louisiana Pacific Smart Side siding, which is a wood composite, very environmentally friendly. Much better than the Hardy in terms of carbon footprint and environmental qualities. And let's see, along the foundation here, I ran the foam all the way down the wall to the footings and then out 4 feet from the foundation because there isn't a frost wall underneath this. For windows, I went with a triple pane Matthews Brothers, and we'll talk about that more when we get inside. So this side of the house, I haven't put the Louisiana Pacific Smart Side on yet, but you'll see this Tyvek. That's just temporary, actually. It's just a protection for the winter because I didn't get done. But underneath that, there's vertical strapping that goes up and down 16 inches on center. So this shows the strapping a little earlier during construction when I was moving the electrical service. And that's what the siding attaches to, so there's a drainage plane behind that. This is something I haven't gotten to yet, is the rest of the foundation insulation on this side. This is just bare concrete right here. Eventually I'm going to dig this up and run the foam insulation down at least 4 inches below grade. This foam, and then I actually used some Roxel board instead because the ants really like to work on the freaking foam and they get into it. So I look down here, see that little section right there? That's where the ants are getting into it, and they'll eat that foam, so you got to protect it somehow. That's kind of a bad spot. I got to get some trim and stuff over this. So I use the Roxel because the ants don't like it, and this block bond on the outside seemed to work pretty well too. So here we are on the inside of the building. It's all gutted out on this side still. I got to get after that, but you can see the foam, that's basically the inner part of the foam. First layer, there's another layer on the outside of that, and that window is placed over the strapping on the outside. Here's how it looks on the outside. I made a picture frame out of 1x6s with 1/2 inch plywood that then extends in the walls like we were just looking at. And then it's all sealed up with 3M flashing tape. Again, this is a triple pane, so you can see how thick that pane is. Probably about 1.1 inches thick. Slightly more expensive, but a lot more energy efficient. To put this window in then, I had to build a box. You see the plywood here and the plywood down here. So I basically built a box all the way around that has strapping on the outside to support the weight of the window, because this window itself is actually just above foam. So the other thing to notice here is this dam. I've got a piece of 1/4 inch rip off a 2x that elevates that so that the water eventually, all windows leak or have condensation and stuff. So taping in a little dam like that prevents the water from coming back into the wall and allows it to drain out to the outside. On the outside of the windows, all the way around the frames, it's taped to the foam. So there's one continuous water, air, and vapor barrier with the foam and the windows all tied together. So that's about it up here. You can see I've got some more LVLs and stuff on the floor here. I got to do some structural work. This is kind of a mess, but we'll save that for another day. So to get back to life cycle costing then, the whole point in doing all this insulation and air sealing is to increase the energy efficiency of the building, so I spend less on energy costs and eventually will break even with the amount of money I put into the insulation and air sealing, and then it'll be a positive effect on my budget. And after I finish all the energy efficiency improvements, I'll move on to step 2, get some solar panels and see if we can make this a zero energy building where it doesn't use any more than it can create. So from this angle you can kind of see the new metal roof that I put on, over 15 inches of new blown in cellulose. And that's about it. We'll talk about more of these things as the semester progresses. Have a good one.